Hello students and welcome. In this video we're going to do some examples from section 5.2 on finding probabilities from the normal distribution. If you look at the examples in the book, what they do is they first standardize the given distribution by using the z-score formula. So this is the z-score formula. Okay. So for example, in example 1, right, we have this normal distribution with a mean of 22, and then the standard deviation of the distribution is equal to 9 hours. Alright, and it's asking you to find the probability a student works for less than 4 hours per week. Okay, and it's the part shaded in blue here is what you're asked to find. So less than 4 hours a week, so the number 4 would be over here on the left. Okay, and because we want to know the probability that a student works for less than 4 hours a week, right, the part of the curve that's shaded is to the left of 4. So what they do then is they take that number 4 and plug it into the z-score formula and convert the number 4 into a z-score, and then they use what's called the standard normal table to answer the question. Okay, so obviously we're not going to do all that. We're going to continue to use the normal distribution calculator and StatCrunch to answer the questions in section 5.2. Let's go and do the first example from the homework. And this is question number 1. And it says, assume the random variable x is normally distributed with a mean of 80 and a standard deviation of 5. And we want to find the indicated probability. Okay, so this notation here, right, with the capital P and x less than 75 in parentheses is asking you to find the probability that x is less than 75. Okay, so x is just some random variable that we know is normally distributed, and the mean of that random variable is 80, and the standard deviation is 5. So whenever we talk about random variables, the random variables have a probability distribution, a mean, and a standard deviation. Okay, so in this case, this particular random variable x is normally distributed with this mean and the standard deviation, and we want to know how often x would be less than 75. Okay, so this literally means probability of x less than 75. Okay, so when we go to the normal distribution calculator, we're going to type in the mean and standard deviation. So go to Stat, Calculators, Normal Distribution. We type in the mean and standard deviation. Okay, and we want the probability that x is less than 75, so we're going to leave the less than or equal to symbol selected, and then type in the number 75 in this box here, and then the probability will be in this box here. Click Compute. Okay, so you have a normal curve, okay, with the indicated probability shaded in the curve, okay, the probability shaded in red here. And we're going to round our final answer to 4 decimal places, okay, like we did in the previous video. Okay, so that's 6 there, which is 4 digits to the right of the decimal point. Right, will get rounded up to 7, so 0.1587 would be the answer. Okay, and you can think of probabilities as percentages, right? So 0.1587, right? So if you have a probability expressed as a decimal, you can multiply it by 100 to convert it into a percentage, right? Or simply move the decimal point 2 places to the right and then add a percent symbol. So about 15% of the time, a little more than 50% of the time, this random variable will be less than 75. So let's go and try another example. I'm going to skip number 2. All right, let's try number 3. Okay, and it says, assume that a random variable x is normally distributed with a mean of 90 and a standard deviation of 4. And we want to find the indicated probability. So the way that we read this is probability. So P stands for probability. So probability of, or the probability that x is between those two numbers, right? So when you see an inequality like this, right, where x is sandwiched between two numbers, and then you have the two less than symbols next to the x, right? This literally means where x is between those two numbers, right? 77 and 83. So we want to find the probability that x is between 77 and 83. Okay, so using our normal distribution calculator, we're going to type in the mean of 90, standard deviation of 4. Okay, because we're finding the probability between two values, we're going to select between. I'll type in the mean of 90, standard deviation of 4. Okay, the lower number goes on the left, okay, and the upper number goes on the right of the interval. So from '77 to '83. Okay, don't worry about the fact that the inequality symbols are less than or equal to. Okay, that doesn't make a difference. Okay, so just realize that the inequality symbols will have the bars underneath them, but that makes no difference in how we calculate the probability. Okay, click compute. Okay, and as is usually the case, we're going to go ahead and round that to 4 decimal places. Okay, so it's a small probability. Okay, so 77 is over here on the left, and then 83 is on the right. So we're finding this area inside the normal curve, okay, between those two values, which is shaded in red. So sort of 4 decimal places. Okay, we get 0.0394, but the 4 gets rounded up to the 5, so 0.0395. All right, and that completes question number 3. Okay, let's look at the next example. And it says that in a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life and 10 represents the best possible life. And it says the responses were normally distributed with a mean of 5.7 and a standard deviation of 2.3. Then we're going to answer parts A through D to complete question 4. Okay, so the part of the problem that's going to help us answer the question is this last part here. Okay, so it says the responses of these people about their happiness, okay, were normally distributed with a mean of 5.7 and the standard deviation of 2.3. So that tells you that we're going to use the normal distribution calculator in StatCrunch. Okay, so we're going to input the mean and the standard deviation. Okay, and part A says find the probability that a randomly selected participant's response was less than 4. Okay, so the keyword here is less than. So you're looking for keywords such as less than, greater than, at most, at least, or not more than. Okay, because that's going to tell you. That's going to tell you the area you're supposed to find, but also the direction of the inequality that you will select. Okay, so less than means you're going to select the less than symbol. Okay, so because we're not finding the probability between two values, right? We're going to go back to standard. Okay, and make sure you have the correct mean and standard deviation. So the probability that the participant's response is less than 4. Okay, so we're going to select the less than or equal to symbol. Type in the number 4 here, click compute, and then the corresponding probability would go here. Okay, so the probability that a person responded with 4 or less than 4, right, is 0.2299. So about a 22% chance that somebody responded with a less than 4 on the happiness scale. Okay, so 0.2299 is the probability. And again, if you convert that into a percentage, it's about 22.99%, or a little less than 23%. Okay, so in part B, we're finding the probability that a randomly selected participant's response was between 4 and 6. Okay, so the mean and standard deviation do not change. Okay, but what we are changing is how we calculate the probability. So we're going to go to between now, and then type in the numbers 4 and 6, and then click compute. Okay, so the probability we're asked to find is shaded in this normal curve shown. Between 4 and 6. Okay, so the 4 decimal places is 0.32197. Okay, so the way that you round this properly is that 9 gets rounded up to a 10. Okay, so the 9 gets replaced with a 0, and then you carry the 1 over to the next digit on the left. Okay, so in other words, the 19 becomes a 20. Right, so when that happens, right, when the 9 gets rounded up to a 10, you replace the 9 with 0, and carry the 1 over to the digit on the left. So 1 plus 1 gets 2, so it becomes 0.3220. Alright, you can try to type in 0.3219, see if it works. Okay, but keep in mind that if you do not round correctly, it might mark your answer incorrect. Okay, but it does accept 0.3219. Okay, it might have also accepted 0.3220. Okay, so keep that in mind. Alright, so in part 2, we're finding the probability that a randomly selected participant's response was more than 8. Okay, so now we're going to go back to the standard part of the calculator, and we're going to select greater than. Right, more than means greater than, and replace that number with 8. Okay, so the probability in question, okay, rounded to 4 decimal places, is 0.1586 or 0.1587. Okay, and then in part D, it's asking us to identify any unusual events and explain your reasoning. So remember, an event is unusual if its probability is less than 0.05. So if any of these probabilities are less than 0.05, the corresponding events would be considered unusual. Okay, so none of these probabilities is below 0.05. Okay, they're all greater than 0.05. Okay, so then you select the best answer choice. So it looks like there are no unusual events, so answer choice A would be the most appropriate. Alright, and that completes question 4 in the homework. Okay, so questions 5, 6, and 7 are very similar, but except in number 7 you're given a diagram of the normal distribution, and you're told that the mean is 21.3 and the standard deviation is 5.3, and you're finding the probability between these two values. Okay. So you would enter this information into the calculator accordingly, so the mean, standard deviation, because you're asked to find the probability between two values, right, you would enter those two values, 2733, in the two boxes here, of course selecting the between option to answer question number 7. Okay, so I'm going to go ahead and go on to number 8. And number 8 says that we're going to use the normal distribution of SAT scores on the critical reading section. Okay, let me rephrase that. So use the normal distribution of SAT critical reading scores for which the mean is 507 and the standard deviation is 119. And it says assume the variable x is normally distributed. Okay, so it's kind of repeating itself. So it says here in the beginning we're using the normal distribution. Okay, and it says here that these critical reading scores in the SAT are normally distributed. So x is the random variable representing the scores on the critical reading section of the SAT. Okay, so the question A says, what percent of the SAT verbal scores are less than 650? Okay, so using the normal distribution calculator, we're going to enter the mean of 507 and a standard deviation of 119. Okay, and we want to know the probability that a score was less than 650. So selecting the standard option, we're going to select the less than or equal to symbol, type in the number 650. Okay, and the probability is shaded in red. Okay, so the 4 decimal places, that's 0.8852. Okay, so this is where you got to be careful because you'll notice that next to the answer box, it has the percent symbol. Okay, so when you see that, you want to enter your answer as a percentage rather than as a decimal, because if you enter it as a decimal, 0.8852, it's going to mark it as incorrect. Okay, so you're going to take 0.8852, which is rounded to 4 decimal places. Okay, multiply it by 100 to convert it into a percentage. Okay, so you get about 88.52% of the SAT scores on this critical reading section were less than 650. Okay, and then on part B of the question, if 1,000 SAT verbal scores are randomly selected, about how many would you expect to be greater than 550? Okay, so now the number's changed here. It's not 650, but now it's 550. So greater than 550. So that's a different probability. So first we get the probabilities for greater than 550. Okay, so we get that decimal, 0.3589, and we're going to multiply it by 1,000, right? So whatever number this is, right, multiply it by the probability as a decimal, so 0.35, multiply by 1,000, and we're going to round that to the nearest whole number, so 359 rounded to the nearest whole number would be the answer, so 359 is the answer. And that completes question 8. Thank you for watching.